So our first thinking or challenge problem says, determine the values of x so that the tangent to the function of, let me rewrite this, y equals 3 over x to the 1/3 is parallel to this line here. Okay, so if the tangent to this function is parallel to that line, that means they have the same slope. So let's rearrange this equation to find slope-intercept form. So we'd get 16y equals minus x minus 3. Divide by 16, so we get minus 1 over 16x minus 3 over 16. All right then. So our slope then is right here. That's our slope, minus 1 over 16. Now the slope is equal to the derivative. So let's find dy by dx. And if it makes it easier, we can write this as 3 times x to the negative 1/3. So first, power rule. So multiply by negative 1/3, which just gives you negative 1. And then times by x. And subtract 1 from the exponent. So we get negative 4/3. Or rewriting that, we get negative 1 over the cubic root of x to the power of 4. Now that is the slope at some point of x. And we know what the slope is that we're looking for. It's negative 1 over 16. So if we set them equal, we can figure out for what values of x this is true. So this just reduces to the cubic root of x to the 4 must equal 16. So that gives you two possible values. X can be 8 or x can be negative 8. So our second challenge problem is a tangent to this parabola. Let me rewrite that. So that's 3x squared minus 7x plus 5 is perpendicular to this line, x plus 5y minus 10 equals 0. So we need to find the equation of that tangent. Okay, so if some tangent to this parabola is perpendicular to this, that means the slope of this line will be the negative reciprocal for the slope of that tangent. So let's rearrange this once again into slope y-intercept. So we'll get 5y equals minus x plus 10. Divide by 5, and we have minus 1 over 5x plus 2. So if the slope of this line is minus 1 over 5, the negative reciprocal is just 5. So the slope of the tangent that we're looking for is 5. Now the tangent, or the slope of the tangent, will be the derivative of this function. So let's find that derivative. So dy by dx equals, so it's just a bunch of power rules. So 2 times 3 is 6, x minus 7. So there's the derivative. And we're going to set that equal to 5. And we're going to solve for the value of x where this is true. Okay, so 6x then equals to, add 7, so 12. And so x is 2. Now, to find the equation of the tangent, we need the slope, which we have, and we need the x and y coordinates. We only have the x coordinate. So what I'm going to do is I'm going to substitute x back into the function to figure out what the y coordinate is. So our y coordinate would then be 3 times 2 squared minus 7 times 2 plus 5. So if we just evaluate that, we get 3. Which means our coordinate then is 2, 3. Now that we have a coordinate and a slope, we can use our slope equation, which is just m equals y minus y naught over x minus x naught. And I'm just going to do this up over here. So the slope is 5. equals y minus our y coordinate 3 over x minus our x coordinate 2. And then we can rearrange that, put it in standard form or slope-intercept form, whichever you want. Slope-intercept form would be 5x minus 7. Our next one says the line y equals 8x plus b is tangent to the curve y equals 2x squared. Determine the point of tangency and the value of b. Okay, so this is getting more fun. This is getting more interesting here. So we have this equation, and this equation is the tangent to this one here, 2x squared. All right, well, what do we know? This is in y-intercept form, so I do know, we know since it's in slope-intercept form, the slope of this line is 8. Right, so m equals 8. So if I found the derivative of this function, dy by dx, which is just 4x, I know I want that tangent to have a slope of 8. So I can immediately solve for where that's going to happen. Well, at least the x-coordinate anyways. So x-coordinate is going to be 2. And since I know the x-coordinate, I can substitute that back into our original function, y equals 2x squared, to figure out the y-coordinate. So 2 squared is 4, times 2 is 8. So where this happens is 2 and 8. Okay, so that's where the point of tangency occurs. But now we need to solve for b. This isn't very different from our previous example. We have a coordinate, we have the slope. Okay, so what I can do is take this equation, y equals 8x plus b, okay, and substitute our coordinate, where y is 8, x is 2, and I can solve for b. So 8 equals 16 plus b, so b is then negative 8. Okay, so number 4, our fourth challenge problem. When I first look at this problem, I was like, ooh, I love this problem. It's a good problem. So let's go through. It's not challenging, but maybe to visualize it at first might be conceptually challenging. So for what values of a and b will the parabola, so we have a parabola, be tangent to the curve here? Okay, so let's just hold on for a second. We have a parabola, and here's the equation of the parabola. X squared plus ax plus b. All right, then we also have some curve y equals x cubed. Now if I were to sort of draw a sketch of this, well, x cubed is something like this. It's a terrible sketch, but you get the idea. And at the point 1, 1, which is, let's say here, 1, 1, this parabola, somehow, wherever it is the not the best graph, but their tangents at that point are the same. So you can say that parabola, or the slope at that point on the parabola, is the same as the slope at that point on the cubic. And we need to figure out for what values of a and b will make that true. So what we're going to have to do is, first, let's find the derivative of our first function. So dy by dx is going to equal 3x squared. Okay, and let's find the derivative of this one too. So for this one, dy by dx equals 2x plus a. Now we know this occurs because it tells us at the point 1, 1. So when the x-coordinate has a value of 1. Okay, so let's figure out what the slope of the cubic would be at that point. So at this point, what is the slope of the cubic? Well, if I set x equal to 1, we have 3, 1 squared, which is just 3. So the slope of the cubic is 3. What this means is that must be the same as the slope of the parabola at that point. So this must also be equal to 3 at x equals 1. So let's write that. So we have 2 times x at 1 plus a must equal to 3. So this gives me 2 plus a equals 3, or just rearranging a equals 1. So we know that the value of a must equal 1. Okay, well if I know a must equal 1, and I know it occurs at that point, I can go back to this function, and I can substitute, let me just rewrite this, plus, I can substitute a as 1, and then I can also substitute the coordinates to figure out what b must be. So the coordinates are just 1, 1. So y is 1, x is 1, plus there's a value for a, there's a value for x. Very easy. 1, 1, 1, 1, plus b. So we get 1 equals 1 plus 1. 1 equals 2 plus b. So b then equals negative 1. And I've graphed these two functions for you. Right, so you can see blue is the quadratic, red is the cubic, right at the point 1 when we have 0.11, when we have those values for a and b. You can see their tangents are identical right at that point. So this last challenge question I quite like as well. So it says find the value of the derivative function at -2 for this function. So let me just rewrite that. So f at x equals ax squared plus bx if the derivative at 2 equals 0 and the derivative at 1 equals 6. Alright, so a couple of tricks here. We need to find the derivative at -2, but we don't know what a and b are. But they do give us some pieces of information here that we can use. So let's first find the derivative. So f prime of x will be 2ax plus b. And now let's use these pieces of information. So we know f prime at 2, which equals, let's substitute 2 in for x. So 2 times 2 gives us 4a plus b. That's going to equal 0. And then we also know that derivative function at 1, so if we substitute 1 in for x, we just get 2a plus b. That has a value of 6. So now essentially we have two equations with two unknowns. We have, let's call this equation 1, 4a plus b equals 0. And let's call the other one equation 2, 2a plus b equals 6. So we can solve these now for a and b. If I subtract the two, we get 4a minus 2a is just 2a, b minus b is 0, and 0 minus 6 is just -6. So a then equals -3. And I can substitute that back into either one. Let's substitute it back into 1. So 4 times -3 plus b equals 0, or b equals 12. So now that I know what a and b are, I can figure out what this is. So our derivative function at -2, right? Remember this here is our derivative function, is 2 times a, and I know a is -3, times x, so x is -2, plus b, where b is 12. Alright, so double negative gives me a positive, so we have 6 times 2 is 12, so 12 plus 12 is 24.